So what is Fluentbit? Fluentbit helps us to create an end-to-end observability pipeline. On this channel, I've covered an introduction to observability, and in that video we talked about the 3 pillars of observability, which are the 3 signals, being logs, metrics, and traces. We talked about how applications and infrastructure can produce these signals, and in order to monitor our infrastructure, we need to be able to collect and receive these signals, process it, and then send it to a destination or storage. Once it's there, we can then use visualization tools to analyze the data. So we need collection, processing, and export of telemetry data. This is where Fluentbit comes in. Fluentbit helps us collect telemetry or signals from various different sources, process it, filter it, enrich it, and then send it off to various types of destinations. Today we're going to be taking a look at Fluentbit, how it works, and how to set up an end-to-end observability pipeline. But first, most of you are not subscribed, so go ahead and smash that subscribe button, click the bell so that you know when the next episode drops. And without further ado, let's go. This video is part of a huge DevOps roadmap initiative. It's a roadmap that brings all of my content to one place. The roadmap gives you a clear starting point, and that takes you on a journey to learn about DevOps. It takes you from Git to source control, to operating systems and Linux and scripting, to Linux monitoring, to HTTP and web, CI/CD and automation, Docker and Linux containers, an introduction to cloud, infrastructure as code, and more. This roadmap is in progress, and here you can see all the indicators of things that are under construction and pre-production, things that are editing, ready to publish. You can see YouTube video content, my course modules, and YouTube shorts, all in one place. Now today's video will supplement the section on observability. Be sure to check the link in the description so that you can explore more content in and around these topics. Now, Fluentbit's main power is its performance and speed. Its ability to go ahead and collect data, process it, and then pass it on to destinations. Now, to get started, we can go ahead and visit the official documentation. And then on the left side here, we can scroll down and head over to the Getting Started section. This will give us all the requirements and different ways to run Fluentbit. There are container deployments like running on Kubernetes or Docker containers. We can install it on Linux. We can install it on Windows or Mac. We can even compile it from the source code. The easiest and most portable way is using the container deployment. So we can use things like Docker. And here you're presented with a simple command to run the Fluentbit Docker image. If you scroll down, you'll see that there are a number of different tags available. And these images are all on Docker Hub. There's a link to Docker Hub right here. You can check it out on Docker Hub, head over to tags, and we can find a suitable tag to use. At the time of this recording, version 4 seems to be the latest. Now if we just take this docker run command and run it, it will run with the default config. If I go ahead and go over to my terminal and paste this command, it'll find the latest Fluentbit image by default and it'll start running. Now notice what it's doing here. You can see that Fluentbit has started up and it's automatically started to report CPU counters. So the default configuration looks like it has specific inputs to read CPU metrics, and then it's outputting that to the terminal. So that's the input and output of this default image. If I press Ctrl C to exit this image, and if I run it again, but this time say --help, you can see that there are a number of command line flags we can actually pass in. And this is quite cool. So when you run the image, you can go ahead and set different inputs like CPU we've just seen, and then you can add processors to process that CPU metrics. You can put filters, and then you can put outputs. And here we see an output like standard out, which is the one we've just seen, as it'll output whatever it inputs into standard out. But what I'm after here is this command line option. There's an option to specify an optional configuration file. This configuration file helps us customize the Fluentbit installation. So we can customize to say what sort of data we want to collect, how we want to process and filter it, and where we want to send it off to. If we take a look at the documentation, you can see that they also have a section how to use a custom configuration file. So it's simple as creating a Docker volume mount, mounting in a local Fluentbit YAML, and mounting it to this expected location. So the default image will look for a config. So in this case, it mounts it into a Fluentbit folder at that location. And then it specifies the location using the -c option we've just taken a look at. So this is how you tell the Docker image and the Fluentbit process to look at a custom configuration file. This means we can create our own custom Fluentbit file, set up our collection, processing and export, and then mount it into the container. So in my monitoring Fluentbit folder, what I'm going to do is create a new file called fluentbit.yaml. And this is our empty Fluentbit YAML where we can set up our collection, our processes and filters, and tell Fluentbit what to do with our data. So in order to learn how to configure Fluentbit, we head back to the documentation. Now that we know how to get Fluentbit up and running, we can click under Administration on Configure Fluentbit and click on the YAML configuration page. This is the YAML configuration for Fluentbit. Now if we scroll down, there are lists of available sections. Firstly is a service section that we need to set up. This is the global configuration for Fluentbit. If you don't set this, the defaults will apply, and you can only have one service section defined. So we need to have at least one service section where we can start putting some default configuration. And if we scroll down, there's more details around the service section over here. And there are a number of keys supported by the service section, like flush. The flush basically tells Fluentbit how often to flush data from input plugins to output plugins. There's a grace period. We have things like log level, which is important. This will help us monitor our Fluentbit instance. We can run an HTTP server, so we can enable it. By default, it is off. This allows us to see a small UI for our Fluentbit instance, and we can bind it on a specific interface, and it can listen on a specified port. The other cool feature is a hot reload feature. This means we can hot reload by passing in a SIG hangup signal. This means we can do automated restarts without restarting the entire process. Fluentbit can then read configuration files when we make changes. So if we scroll down, we'll see a configuration example. Here's a service example with a flush, log level, an HTTP server, hot reload on, and a pipeline with one input and one output. What I'm going to do is just copy this, go to our empty YAML file and go ahead and paste that in there and save it. And what I can do now is I can go ahead and do Docker run, and I can expose the port for the web server so we can have a look at that, and I can mount in that config file, that YAML file I created earlier, and we're mounting it to this location, and we specify this location in the --config flag. So we tell Fluentbit where to find the configuration file and not to use default values. So I go ahead and copy that. In my terminal, I paste it, and now Fluentbit has started running. But now look at the inputs and outputs. So we've got that random input that we've specified here, and it's outputting it to standard out to our terminal. And this match indicates we want to match everything. So you can see that's what's happening. Random numbers are being generated by input and spat out to the terminal via output. We can also head over to localhost on port 2020, and we can see the web interface that Fluentbit creates. It tells us what version of Fluentbit we're running and the flags that are enabled. The next important configuration section we want to take a look at is called the pipeline section. If we go back to the documentation, under the configuration section, we've talked about the service section that contains the global configuration. The next one is called the pipeline section. This is the second most important one because the pipeline section is composed of everything else. So everything such as inputs, which defines where we get our data from, and processes and filters, which is what do we do with our data, and output plugins, which is where do we send our data. All of that gets stitched together via a pipeline. So the pipeline stitches together inputs, processes, filters, and outputs. And if we scroll down on the documentation, you'll find each section document here. We've covered service, and now we'll go to pipelines. So the first important component we'll take a look at is inputs. Inputs specify the plugins that are responsible for collecting or receiving data. So they can either be receiving, such as HTTP, so we can open up a port and then listen for data coming in. So we can receive logs over HTTP. This is similar to an OpenTelemetry receiver. Or we could go ahead and collect data. This is one like Tail. We can use the Tail plugin to look at files and grab data. We can also use inputs such as Prometheus to go ahead and scrape data from a Prometheus endpoint. To give you an idea of inputs, you can get data from Kubernetes, Prometheus, OpenTelemetry, Linux, syslog, and more. So we can either go out and collect, or we can receive and have systems send data to us. The next most important section under pipeline is outputs, and this defines destination for processed data. Outputs specify where the data will be sent. We can send it to remote servers, we can write data to a file, we can write it to the terminal such as standard out, we can send it to things like Prometheus, OpenTelemetry, Elasticsearch. There are many output plugins available. If we take a look at our example YAML file, we have our service section, then we've defined a pipeline, and we have an input plugin over here. The inputs is an array. We can have multiple plugins, so accept multiple inputs or receive and collect multiple sources of data. And then we have an outputs section, which is an array of output plugins. So this is a very simple plugin that just generates random data. This is used for testing or demo purposes. Then here we have a standard output plugin which writes to the terminal. Output plugins can also have a match on what to output. This can help us drop noise. And that is what we see in the output when we run this container. We have random data being generated and then output to the standard out terminal. So let's go ahead and create our own pipeline. Now to do this, what we'll need is an input. Inputs allow us to collect data from various sources. Inputs can go and read files, it can read from HTTP endpoints, and it can also have an HTTP endpoint where other clients can send us data. If we take a look at the documentation and we scroll down to data pipeline, you'll find the inputs section. And this tells us the role of inputs. Inputs gather information from different sources. We can collect data from log files and others, or we can gather metrics. We can also use it to gather traces. So it's the entry point for data in our pipeline. If we take a look at the side panel here, these are all the types of inputs we can use. So we can go ahead and install Fluentbit on a server and get CPU metrics. We can get disk I/O metrics, Docker events and metrics, eBPF, Elasticsearch. We can use HTTP. So that means people can send data to us, such as log metrics or traces. We can have an OpenTelemetry input, so we can accept data from an OpenTelemetry collector. We can get Prometheus data. Tail allows us to read files, so you could use this in something like a Kubernetes cluster to read pod logs, and Windows event logs. So one very powerful type of input is the Tail input plugin. This one allows us to monitor text files. It's similar to the tail command in the command line, and this allows us to read files such as log files, so we can use this to read things like Docker logs, pod logs, or any kind of web server logs on a server. This is a very powerful and popular input type. To show you an example of this, you provide an input, give it the name, tail, and then give it a path of what file to read. So you could read something like syslog files. In my examples, what I've done is created an input plugin that we can use using the tail plugin. And what I do is I actually go ahead and read container logs. So if I copy this input plugin, go to my Fluentbit YAML, go ahead and paste that and remove the random plugin, I can use this plugin to go ahead and read Docker container logs in the default location where container logs are written. So that is a very popular type of input plugin. Another very popular type of input plugin is the HTTP endpoint. This allows us to have Fluentbit open an HTTP port and then route data in a dynamic way. So here we can specify what interface to listen on, a port to listen on, and we can basically create an endpoint where clients can send us data. We can then send that data almost anywhere. And here's an example of an input type HTTP. You just give it an interface and a port. So in my README file, I've got that as an example. I go ahead and copy that, go to our Fluentbit YAML, and let's go ahead and paste that in. So now we'll have two popular types of inputs. We can accept logs or metrics or traces over HTTP, as well as read container log files. Now note here that I'm listening on port 8888. So we need to expose that on our Fluentbit container, as well as mount in varlib docker, because that is where the Docker daemon will be writing container logs to. So we need to give our Fluentbit access to that folder. So here's the updated docker run command. Say docker run, open up our two ports, our two volume mounts, mount the configuration in, give access to the varlib docker folder. So now we can hop into the terminal. We can go ahead and run that command. And as you can see, the terminal is getting really busy really quickly. This is because I have quite a lot of Docker containers running on the system. This is because since we are reading all of the container logs, and we're also outputting everything to standard out, which goes back to the container logs, we basically have a circular loop. But I'll show you how to deal with that in a bit. This is technically how you read logs. So what I'm going to do is just quickly comment out this input plugin, just so I can show you the HTTP one. If I go to the terminal and start up my container now, and in another terminal, what I can go ahead and do is test our HTTP endpoint by running this curl command. So let's say we want to send a payload to Fluentbit from a specific service. Let's say we're coming from the product namespace and we want to send a message from one of the products APIs, and we're passing that through to our Fluentbit instance. We can go ahead and run this curl command, and if we go back to the Fluentbit output, the standard output, we can see we managed to record that event. Now, output plugins is designed for us to specifically send data that we have received and processed to destinations. We can output data anywhere. We can do it to standard out like we've been doing. We can write it to file. We can send it to S3 buckets. We can send it to OpenTelemetry. We can send it to storage if it's logs, something like Grafana Loki or Elasticsearch. If it's metrics, we can send it to something like Prometheus. And if it's traces, we can send it to something like Grafana Tempo. So it's important for those three pillars of observability. So now that we have our input plugin, we want to go ahead and define some output plugins, what to do with the data we received. And if we head back to the documentation and we scroll down all the way to the data pipeline, you see we have output plugins over here. Outputs let us define destinations for our data. So we looked at the front of the pipeline. This is the back of the pipeline. We can send data to remote services, local files, and other standard types of interfaces. And if you take a look at the document on the left side, you can see all the places where you can send data to. Amazon S3, Azure Blob, Elasticsearch for logs. A file is a very popular one for troubleshooting purposes, so you can see what you've collected or what you're processing and filtering. You can forward it on to other Fluentbit instances. You can forward it on to HTTP, Google BigQuery. You can even send it to OpenTelemetry, so you can make Fluentbit part of an OpenTelemetry observability pipeline. You can send things to Prometheus if you're dealing with metrics and more. In our README file, I have an example of an output. We're currently using standard output, and I know that there was a problem with it because we had that circular issue. So let's replace the standard out option with a file output. So here what I'm doing is I say the name is file. This is the file output plugin I want to use. I want to go ahead and match everything, and then I want to write it to file in my data volume. And what we'll do is we'll add a volume called .data, where we'll persist local data so we can have a look at the files that are collected. This is great for troubleshooting, so we can test our input plugins, but we can also test processing and filtering. So let's go ahead and copy this, go to our Fluentbit YAML. We can go ahead and enable our tail plugin again. This time I'm going to replace the output plugin, and I'm going to go ahead and just paste my output plugin in there. If we take a look at the configuration file for this output plugin, we can see that the output plugin allows us to take any data we receive and write it to file. So here we can configure things like a path, where to write it, the directory, a specific file name. We can do format. So formats allows us to do plain text, CSV, or even templating. So you can create a template for the output that you've received. The templating allows you to define a template of how you want to structure the messages coming in. So here I'm just going to write the whole log file output. and I'm going to write all the output that I receive into this .data folder. For that to work, I just need to add that extra volume mount and add that .data folder, which I've added over there. We can go ahead and take this docker run command. We can head over to the terminal, paste that one, and now we can see the terminal got quite busy as all the container log files have been read. If we go to VS Code, we can see our .data folder was created over there for that mount. We have a tail file over here, and we can see all the container logs are coming in. So any container that we run where Docker picks up its logs, our Fluentbit instance will read those logs now. Now, there are some other concepts to understand with Fluentbit about its functionality and how it works. If we go back to the documentation and we look on the right-hand side, there is a concepts section. And there are some key concepts that we need to understand when working with Fluentbit. So what are events or records? Events or records are pieces of data that belongs to a log or a metric or trace that's received by Fluentbit. It's considered an event or a record. So anything coming into Fluentbit is called a record. So if I go to our terminal and we do that curl command again to our Fluentbit endpoint, and then we take a look at this log that was written in our .data folder, you will see the format in which Fluentbit writes events. This is an event that we've just received. So taking a look at an event consists of a timestamp, key value metadata, and a payload. Here you can see a tag, a timestamp, and our payload for our JSON. This is the message that we send through via curl. So you can see that the event follows a specific format. You have timestamp, metadata, and message. Next up, you have filtering. Filtering is used if you need to modify events content. This allows you to alter an event, append, so you can enrich. Think of things like if you're running in Kubernetes, you want to add pod names, node names, and things like that. So you can enrich, or you can drop noise. Think of things like health probes or noisy logs or metrics. So it's useful to append information like IP address or metadata, select a specific piece of event content, or drop events that match a pattern. We can also have tags. Every event that is ingested by Fluentbit is assigned a tag. The tag is an internal string that is used later by the router to decide which filter or output plugin phase it must go through. So we can use tags to say all of this input goes to a specific output plugin. Next up, I want to show you an example of a filter. In production environments, you need full control of the data you're collecting, and filters allows you to alter the collected data before delivering it to a destination. And filters are also implemented through plugins. So if you take a look at the left side over here, there's a bunch of filters available. One of them is like grep. If you're familiar with Linux, grep allows you to select a portion of data. So if I go into grep allows us to select or exclude records using regular expressions. So we can use regex to either match records, or we can use exclude with regex to say exclude certain types of records. This allows us to achieve filters. So we can go ahead and write a filter plugin that only includes requests from the product namespace. So what I can do is use the grep plugin. I can say match everything, but then run regex on it. I only want data where the namespace field equals product. So I can go ahead and copy this, go to my Fluentbit YAML, and I can create this filters section with my grep and its content. That means now that if I run a curl command, let's run it a few times, we can see we've received all of the logs. These are from the product namespace. If I have another namespace such as the search namespace and I run that, we will see that we are not receiving that log. This is because we are only looking for specific fields such as namespace and matching the value product as per our regex over here. We can also use the exclude option to say accept anything, however, just exclude the search namespace. So I can flip that around and say go ahead and exclude the search, but include everything else. So now if I run a few curl requests for the namespace search, you can see it's still not allowing search. I can run product, and product is still being accepted. And I can try another namespace such as cart namespace, and we can see it's allowing that. So it's allowing everything excluding search. So that is an example of a filter. So that's a basic introduction to Fluentbit in a nutshell. Hope this video helped you understand the basics of Fluentbit, how to get it up and running, and how to work with the configuration and the documentation. If you liked the video, be sure to like and subscribe and hit the bell, and be sure to check out the roadmap link down below to find all the content in one place, and so that you can follow its development. And if you want to support the channel even further, be sure to hit the join button down below to become a YouTube member. And as always, thanks for watching, and until next time, peace.